Imagine your mind is, well, perfectly sharp.
Right.
But suddenly you realize you just can't button your shirt.
It's a terrifying thought.
It really is. And you go to a doctor and they tell you that your body's main motor control grid is just systematically shutting down.
Yeah.
They say your muscles are going to atrophy, your speech will slur, and there isn't even a single blood test that can definitively prove why it's happening.
Which, has been the heartbreaking reality of neurology for decades.
Exactly. For the longest time, it was a field famous for these brilliant diagnostic deductions, but completely unable to offer a cure. They could only watch it unfold.
But that is finally changing.
It is, and that's exactly what we're looking at today.
Welcome to the Deep Dive. We are exploring a massive shift in medicine, guided by a really comprehensive review on amyotrophic lateral sclerosis and other motor neuron diseases.
The author poses this profound question, has neurology finally moved from the rear guard of just observing to the actual vanguard of therapeutic innovation? Right. Because we are moving into an era where doctors can intervene at the genetic level.
We really are. But to understand those new treatments, we first need to unpack the complex reality of ALS and the diseases that surround it.
So for you listening, we're going to break down the biology of why muscles fail, the crazy detective work needed for a diagnosis, and those cutting-edge genetic therapies.
Let's set a baseline first, though. What actually is a motor neuron disease?
Good place to start.
Basically, the motor system runs on a two-part circuit. First, you have the upper motor neurons, or UMNs.
And those are up in the brain, right?
Exactly, in the primary motor cortex. Their long fibers project all the way down the spinal cord. And then second, you have the lower motor neurons, the LMNs.
Which sit in the brainstem and spinal cord.
Right, and their fibers project directly out to your specific muscles to make them move.
I like to think of it like a massive IT network.
Oh, that's a good analogy.
Yeah, so the upper motor neurons are the central cloud servers, right? Routing all the complex, high-level commands. And the lower motor neurons are the physical Ethernet cables running from those local routers straight into the hardware of your muscles.
That's spot on. And ALS is so devastating because it attacks both the cloud servers and the local cables at the exact same time.
Which means the clinical presentation looks drastically different depending on which part of the network crashes first.
Exactly. So if the central servers, the upper motor neurons, fail, the local hardware is actually still intact.
But it loses its boss, basically.
Yeah. It loses that regulatory oversight.
Yeah.
So without the dampening signal from the brain, the spinal reflexes just go into absolute overdrive.
The muscles get stiff and spastic.
Yes, movements become really slow and strained, and reflexes are hyperactive.
But what about when the local Ethernet cable fails, the lower motor neuron?
Well, then the muscle receives absolute zero input. It essentially starves.
It physically shrinks.
Right, a process we call atrophy.
Yeah.
And it also triggers, one of those visible hallmarks of the disease fasciculations.
Those are those tiny involuntary muscle twitches right beneath the skin, right?
Yeah, because when a lower motor neuron dies, the orphan muscle fibers get desperate for any kind of signal.
It's called denervation hypersensitivity.
Exactly. They spread new receptors all over their surface, hoping to catch some stray neurotransmitter, which causes them to spontaneously misfire and ripple.
And the review mentions this brilliant clinical trick for spotting them.
Oh, the flashlight trick.
Yes. You don't use the harsh overhead lights in the exam room. You turn them off and use indirect lighting.
You shine a flashlight horizontally right across the skin.
Right, and you just watch the resting muscle for like 30 to 60 seconds. The shadows make those subtle misfires completely obvious.
It's a great example of the meticulous detective work required because, ALS is incredibly heterogeneous.
Yeah.
It rarely starts the same way twice.
Demographically, it primarily hits between the ages of 60 and 75, right?
Yeah, affecting men slightly more often than women. And the established risks are things like age, family history, and smoking.
But the environmental risks are where it gets really mysterious. Like, participating in sports with high concussion rates increases your risk.
And exposure to heavy metals and pesticides, too.
But the craziest one to me is military service.
It's a really striking anomaly.
Just serving in the military carries a higher risk of developing ALS, and it doesn't even matter what branch you were in or what area you served in.
We suspect it's a combination of environmental exposures and intense physical stressors, but honestly, we still don't fully comprehend it.
So when it does show up, it usually falls into one of three main presentations, right? Each is about a third of cases.
Right. Lower limb onset is often the sneakiest.
A patient might just notice a foot drop. They start tripping over rugs or their foot slaps the pavement.
And because it's painless, it gets brushed off. People think it's just a pinched nerve in their lower back.
Then there's upper limb onset. That usually starts distally, right at the ends of the limbs.
Yeah, so fine motor skills go first. You can't turn a key in a door, or you struggle to pinch a zipper.
And the third one is bulbar onset, which sounds like the most aggressive.
It is. It attacks the motor neurons controlling the face, head, and neck.
So patients get dysarthria, difficulty speaking, and dysphagia, difficulty swallowing.
And because both the upper and lower systems are crashing, the voice becomes this confusing mix of like strained spasticity and a breathy tone.
Plus the physical wasting of the tongue. That's a stark clue, right?
Yeah, the tongue actually atrophies, giving it this corrugated raisin-like appearance.
Wow. And the bulbar region also introduces a really misunderstood symptom.
You mean the pseudobulbar effect?
Yes. Since the upper motor neurons in the brain are degenerating, patients lose that inhibitory control over emotional reflexes.
So they experience these uncontrollable bouts of laughing or crying.
And it totally doesn't match how they actually feel. Like they might start weeping hysterically over, I don't know, a comment about the weather.
It's a profound disconnect. And it's incredibly distressing for the patient because they are trapped inside an emotional reaction they literally cannot stop.
It's just devastating. So if classic ALS is the destruction of both systems, what happens if only one system breaks down?
Well, that introduces the clinical variants,
Yeah.
like primary lateral sclerosis or PLS.
That's isolated upper motor neuron degeneration, right? The central servers crash, but the local cables are fine.
Exactly. These patients develop progressive stiffness, spasticity, and imbalance, usually in the legs, but without the severe muscle wasting.
And on the flip side, there's progressive muscular atrophy, or PMA.
Right. That's isolated lower motor neuron failure. Pure weakness, atrophy, and fasciculations with no spasticity.
Wait, so if they only have half the pathology, is it actually still ALS? And does it change their prognosis?
Usually these isolated variants have a much more favorable prognosis. Progression is slower and survival is significantly longer.
That's good news, at least.
It is, but the catch is that over a period of years, many of these variants eventually cross over. The other system fails and it evolves into classic ALS.
It just highlights how unpredictable this disease is. Like that bizarre case study in the review, the flail leg variant.
Oh, that's a fascinating one.
A man had severe lower motor neuron weakness, completely confined to his legs, and it just stayed locked there for 5 full years before spreading to his hands.
And that kind of isolated progression forces doctors to constantly watch out for mimics. There are genetic conditions that totally masquerade as ALS.
Like Kennedy disease?
Right. It's an X-linked disorder, mostly hitting men, that causes lower motor neuron weakness.
But it throws in symptoms ALS usually spares, like sensory issues. With ALS, you lose motor control, but you can still feel everything perfectly.
Exactly. Kennedy disease compromises both. And bizarrely, it introduces endocrine dysfunction.
Which seems completely out of place for a motor neuron disease.
It really does. It's caused by a mutation in the androgen receptor gene. So not only is it toxic to the motor neurons, but the faulty receptors make the body deaf to testosterone.
Resulting in things like enlarged breasts in men and reduced fertility.
Yeah. Another mimic is monomelic amyotrophy, or Hariyama disease.
That one is so specific, it almost exclusively strikes young men in their late teens or 20s, right?
Yes, presenting as asymmetric weakness in just one arm. But the pathology is mechanical, not neurodegenerative.
It happens during adolescent growth spurts. The protective sac around the spinal cord doesn't grow fast enough.
So when these kids flex their necks forward, the tight sac flattens against the spinal cord and compresses it.
And to diagnose it, a standard MRI won't even show anything.
Right, the radiologist has to scan them with their neck aggressively flexed forward just to catch the compression happening.
Which brings up a massive question for me. With all these variants and mimics, how do you actually lock in a definitive ALS diagnosis?
Well, you rely heavily on clinical deduction. There's no gold standard biomarker.
No blood test, no ALS protein you can just find.
No, we use the Gold Coast diagnostic criteria, which demand evidence of progressive motor impairment and the absolute exclusion of any other disease.
And the main tool is the EMG, electromyography.
Right. We insert fine needle electrodes directly into the muscles to listen to their electrical activity.
You're hunting for that desperate electrical chatter from the orphaned muscle fibers.
Exactly. To confirm ALS, we need to document that denervation across multiple regions. The bulbar muscles, the cervical spine, the thoracic spine, and the lumbosacral spine.
It's kind of counterintuitive though. I mean, if The upper motor neurons in the brain are dying. Shouldn't we just see that on an MRI?
We do use MRIs a lot, but mostly to rule out structural issues like a herniated disc.
But there is that one marker, the motor band sign.
Yes, that is a distinct marker.
It literally looks like a dark streak running through the motor cortex on the scan, showing the tissue loss, and it shows up in like 80% of ALS patients.
True, but since it can occasionally appear in healthy aging brains, it isn't specific enough to be the sole diagnostic trigger.
Makes sense. And the diagnostic criteria have really had to evolve regarding cognition too.
Absolutely. We used to think the mind was left entirely untouched.
Right, this idea of a perfectly lucid intellect trapped inside a failing shell.
But the data tells a much more complex story. About 15% of ALS patients actually develop frontotemporal dementia, or FTD.
And that's not the memory loss kind of dementia like Alzheimer's.
No, FTD attacks the frontal and temporal lobes. It fundamentally alters behavior and personality.
Patients might develop profound apathy or impulsivity or just completely lose their empathy.
It's incredibly hard on families. They're dealing with the physical decline, but also losing the personality traits of the person they love.
And understanding that cognitive link is what pushes us directly into the realm of genetics, which is where the vanguard of treatment is right now.
Definitely. Historically, we split ALS into two rigid categories. Sporadic, which was 90% of cases, and familial, which was 10%.
But that boundary is completely dissolving now.
The whole paradigm has shifted. We're now considering genetic testing for all patients, regardless of their family history.
Because we're finding that even seemingly sporadic cases harbor pathogenic genetic variations.
Right. The most common culprit for both ALS and FTD is a variation in a gene called C9orf72.
That's the one with the massive abnormal expansion of DNA building blocks.
Exactly. And identifying that mutation fundamentally changes the conversation about a patient's risk for cognitive decline.
And it dictates the therapeutic strategy too. Because the historical drugs like riluzole and edaravone, they only offer modest benefits.
Yeah, they slow progression and extend survival by a few months, but they don't stop the disease.
Because they only act on the downstream damage. Right. Riluzole tries to turn down the excitotoxicity.
Right, because dying motor neurons release massive amounts of glutamate, which basically overstimulates neighboring neurons until they fire themselves to death.
So riluzole blocks that, and edaravone is a free radical scavenger, soaking up the toxic exhaust from the dying cells.
But again, that's just damage control. The true vanguard is targeted gene therapy.
Like the FDA's recent accelerated approval of tofersen, this feels like a watershed moment.
It absolutely is. Tofersen is an antisense oligonucleotide, specifically for patients with a mutation in the SOD1 gene.
So an antisense oligonucleotide is basically a biological interceptor.
That's a great way to put it.
The mutated gene produces toxic proteins that kill the neuron. So tofersen binds directly to the messenger RNA, the instructions from the gene, and destroys them before the protein is ever made.
We are turning off the genetic faucet instead of just mopping up the floor.
That level of precision is just unprecedented. And researchers are also looking at stem cells, right?
Yes, there were recent phase 3 trials injecting mesenchymal stem cells directly into the spinal fluid.
Now, I know they failed to meet their primary clinical endpoints. They didn't halt the physical weakness.
They didn't. But burying it as a failure misses the underlying science entirely.
Right. Because when they analyzed the cerebrospinal fluid, they found significant improvements in biological markers of neuroinflammation.
The therapy successfully altered the toxic microenvironment around the neurons.
Which proves we can biologically manipulate the central nervous system, even if it didn't translate into immediate physical strength yet?
Exactly. But, while those genetic therapies mature, a patient's immediate survival really depends on symptom management.
The multidisciplinary clinic, which reminds me of a Formula One pit crew.
That's the perfect analogy. The American Academy of Neurology is very strict on this.
Wow.
You cannot manage this disease with just a single physician.
You need a highly coordinated crew working on different systems at the same time. Neurologists, respiratory therapists, dietitians.
Because the data proves that this team-based approach significantly extends survival and improves quality of life.
And they're basically fighting a war on two main fronts: breathing and eating.
Yes, as the muscles weaken, the patient loses the mechanical ability to pull air into their lungs.
The trigger point for intervention is when the forced vital capacity drops below 50%, right?
Right. At that threshold, respiratory therapists introduce non-invasive ventilation.
Like a specialized pressurized mask worn at night.
It physically assists the chest in expanding, which reduces the massive caloric strain of fighting for breath.
And that ties directly into the second front, nutrition. Dysphagia makes swallowing liquids terrifying because of the choking risk.
Meanwhile, the body goes into a hypermetabolic state. The patient is burning calories at an accelerated rate while physically unable to eat.
Up to 50% of patients face severe weight loss. So the solution is a gastrostomy tube, a feeding tube placed right into the stomach.
But the timing of that is a very delicate balancing act.
You have to place the tube before their respiratory capacity drops below that 50% mark.
Exactly, because placing the tube requires sedation, which is a risk to the airway. If you wait until the lungs are severely compromised, the procedure itself becomes life-threatening.
So the team has to project the disease's trajectory and intervene while the patient still has the reserves to handle the operation.
Which naturally leads to the hardest question every patient asks. How much time do I have?
Prognostication, how do you even answer that?
It's incredibly difficult. We use frameworks like the King staging system, which tracks how many regions of the body are currently failing.
Or the ALS survival model, which uses 8 variables like age, respiratory function, and genetics to place patients into statistical survival groups.
And those groups range from a median survival of 17 months on the aggressive end to 91 months.
But they're just statistical probabilities. They don't give you an exact timeline for the actual human being sitting right there.
No, they don't.
The journey through motor neuron diseases is just a study in brutal complexity. We've traced the circuitry, navigated the mimics, and seen how a multidisciplinary pit crew keeps the body functioning.
And we are watching in real time as targeted therapies like tofersen rewrite what neurology can actually do.
Moving from observation to intervention is monumental, but man, it brings up entirely new ethical landscapes.
As therapies get more hyper-targeted, we are approaching a reality where predictive genetic testing might become standard for healthy people.
And that's the thought I want to leave you, the listener, with today. If a family member was diagnosed tomorrow, and you were offered a test for the C9orf72 or SOD1 mutations, would you take it?
It's a heavy question. Knowing your genetic destiny alters the psychology of your life today.
Especially since the cures are still in their infancy, you have to balance the hope of early intervention against the weight of incurable knowledge.
It really is the ultimate consequence of pushing medicine into the future.
It is. Thank you for joining us on this deep dive. Keep questioning, keep exploring, and we'll see you next time.